Hey, and welcome back to another exciting episode of Mr. Takeda's teaching probability, Math 7. Hey, this is lesson 10.4 on compound events. What do we mean compound? Well, that's when we put two or more things together. And our question is, how can you find the number of possible outcome of one or more events? Compound events. Okay, so first of all, a little bit of vocabulary for us here. The set of all possible outcomes of one or more events is called the sample space. Okay, so now we've got all possible outcomes of one or more. And we can use tables and tree diagrams. Let's take a look what that means here. Okay, you randomly choose a crust and style of pizza. Find the sample space. How many different pizzas are possible? All right, we're going to find the sample space here. We have two different types of crust. So here's how we do a tree diagram. Thin, stuffed. Two different types of crust. Now for each of these crusts, I can have one of four styles. So I could have thin Hawaiian. I can have thin Mexican. I don't know what a Mexican pizza is. I don't know. I want to know. I can have thin pepperoni. Boring. Thin veggie. Even more boring. Go for the Hawaiian. I can have stuffed Hawaiian. I'm running out of room. I can have stuffed Mexican. I can have stuffed pepperoni. Pepperoni. And I can have stuffed veggie. How many different types can I have? I can have 8 different pizzas. Okay, so there's our sample space. Thin Hawaiian, thin Mexican, thin pepperoni, thin veggie. Stuffed Hawaiian, stuffed Mexican, stuffed pepperoni, stuffed veggie. That is our sample space. Okay, you go ahead and answer this question. You don't have to find the sample space, but you're going to answer the question, how many subs are possible here? Okay, so go ahead and pause this and join me on. Now we're going to talk about something called the fundamental counting principle. All this, look at all this. Oh my gosh, there's so many words here. An event M has M possible outcomes. An event N has N, little n, possible outcomes. The total number of outcomes of event M followed by event N is M times N. So let's take a look back at the first example. We just did it. We had two different crusts, right? We had 2 different crusts times 4 different styles of pizza. You know, we had the thin crust and the stuffed crust, and then we had the Hawaiian, Mexican, pepperoni, and veggie. So we had 8 different possible outcomes. That's the fundamental counting principle. All right. Example 2 then, finding the total number of possible outcomes. I like how a lesson kind of rolls together here. Find the total number of possible outcomes of rolling a number cube and flipping a coin. Use the fundamental counting principle. Identify the number of possible outcomes. Okay, well, for a number cube, there are 6 possible results, and then for flipping a coin, there are 2. So the answer to this number of possible outcomes, 12. Think about it. If my dice I roll 1, then I can follow that with the heads and the tail. If I roll 2 on the dice, I can follow that with the heads and the tail, and so on until I get to 6, and then I have heads and tails. So 6 times 2 is 12. Try to answer this question. Find the total number of possible outcomes of rolling 2 number cubes. All right. Go ahead and pause it. Figure that answer out, And join me on this. Oh, let's take a look at this. Excuse me. How many different types of outfits can you make from the t-shirts, jeans, and shoes in the closet? Okay, so let's take a look. It looks like we've got 4 sets of jeans. And t-shirts, we've got 1, 2, 3, 4, 5, 6, 7 jeans. And shoes, we've got 1 pair, 2 pair, 3 pair, 3 pair. Right? We're going to multiply all these together. 4 times 7 times 3. Okay, I'm going to do this kind of easy, right? Because 4 times 3 is 12. And 12 times 7 would be 84. 84 different outfits you could make from what's in this closet. I find it interesting that they put their t-shirts on hangers and stick their jeans up there. I personally put my t-shirts on the shelf and hang my jeans. It's so interesting how people are different. Okay, try and answer this question. How many different possible outfits can you make from 5 t-shirts, 3 pairs of jeans, and 2 pairs of shoes? Go ahead and pause it, figure that out, and join me on the next. Okay, so here we are at example 4. Now it says in example 2, what is the probability of rolling a number greater than 4 and flipping tails? Okay, so if you remember in example 2, we were asked to find the total number of possible outcomes of rolling a die and flipping a coin. And the answer was 6 times 2, it was 12. There are 12 possible outcomes. But let's talk about the possible outcomes, the desired outcomes of rolling a number greater than 4 and flipping tails. Okay, so what numbers do we? So they only have 5 followed by tails and 6 followed by tails. So there's only 2 possible. So it's the probability of greater than 5 and tails. So there's 2 possible out of, we had 12, two desired results out of 12 possible, so 1/6. 1/6. Can only be 5T and 6T. 5 tails and 6 tails. So there's only 2 out of the 12. All right. Let's look at example 5. Finding the probability of a compound event. You flip 3 nickels. What is the probability of flipping 2 heads and 1 tails? Okay, so on the first nickel, we can either have heads or tails. The second, the second nickel, we can have either heads or tails. And the third nickel, we can have either heads or tails. So it's 2 times 2 times 2. So there's 8 possible outcomes, and here they are. 1, 2, 3, 4, 5, 6, 7, 8. Now we want to know the probability of 2 heads and 1 tail. Out of these 8 possible outcomes, 3 of them meet that requirement. Heads, heads, tails, heads, tail, heads, and tail, heads, heads. So that's 3 out of 8, which is 0.375 or 37.5%. Maybe 38%. Okay, so again, it's just the desired results out of the total possible rate. Okay, that is it for today's video. Hope you found it entertaining. Thanks a lot, and I'll see you next time. Bye-bye.